All right, so welcome back, guys. So I'm going to be showing you the continuation of the two builds I'm doing, the Newman motor and then this motor that's made out of the filament spool. First, I'd like to address something that I was unaware of, and I'm grateful for the commenter to alert me to this thing that I was doing. Apparently, you can hear me macking on gum in the video, and it's very distracting. And I apologize. I'm not a very good videographer. Um, I do this just for fun, but I'm going to make a uh, concerted effort to not chew gum into the mic when I'm recording these videos. It's very unprofessional, and I can imagine it must be really annoying. Anyway, moving on. I printed out this guide, I'm calling it. It's a template so that I can install these systems inside inside the spool holder. If you remember from the last video, I wanted to make something that would so these will be glued down inside and up top in 8 different positions so that this magnet setup can slide in and out like this. All right, if you can grasp that idea. And so I printed out 16 of those, two for each position. And if you guys are not familiar with, for those who are not familiar with 3D printing, there's a thing called a brim, so that when you print either small objects like this or very large objects, you add some extra material around the edge to either hold it in place on the printer bed or stop it from lifting up, stop it from warping. In the case of small objects like this, it's to hold it down. I find using a brim very helpful. Unfortunately, it leaves a little edge all the way around. And for something like this, I can't have that edge on there. All right, it's got to go smoothly like this. See if you can see the action there, like that. So I had to deburr every single one of these, and there's 16 of them. And it was a huge hassle because my arthritic hands have an issue sometimes holding small parts, but I'm not going to let any type of disability on my end stop me from doing this type of stuff. Anyway, so I'm working on this one. I'm also working on the Newman motor, which the two halves are now complete. I still need to glue on the um, the brim or the yeah, the brim piece like this, which is going to hold the um, the magnet wire in place. And I got the putty. I also got um, the special resin that works with 3D prints, because I'm going to putty the gaps or any type of misalignment I had putting those halves together. I also ordered um, some N52 magnets of the same dimension as these, and they came in. And so for the center one, I'm going to replace the center one of all these with a higher quality magnet, one that has more magnetic flux. And again, these are going to sit right inside here like this. And some there's some question on whether this is actually going to work or not. And the only way to find out is to actually build it and do it. I think by adding a stronger magnet in there, And again, here, let me back this up so you guys can see this. Again, this piece is going to be glued down there, and then this piece is going to be glued behind it so that this guy can slide in and out so I can replace it. And again, there's also going to be one on the top. So I'm going to do that gluing today. Yeah, so I'm going to get the Newman motor out of its clamps, take a look at it, and then glue the rims, or I'm not sure what you'd call it. I guess you'd call it a rim. I'm calling it a rim, on the top and the bottom of each of those cylinders down there, and let that dry. It takes 24 hours because I'm using that acrylic glue number 16, which is really good. But I'm excited for both of these, especially the Newman motor. But I've been doing a lot of work on this one because there's a lot of prep work. Like I had to print out this guy and print out all of these little pieces. And so now, with the aid of this guide, I'm going to glue these, because this is an exact replica of this piece, simply solid and raised up, as you can see. So it's the exact same size, which is one of the great things about 3D printing. You can reproduce stuff pretty accurately. Anyway, stay tuned. Okay, guys, welcome back really quick. So it's not glued up except for the segment parts. I just kind of stacked it to show you what it would look like. This is the size of the Newman motor. This is how it's going to look. Although I'm looking at it now and I think I have too many segments. I think I need to take at least one segment off of each half, because I think it's too tall. Because remember, I can only have the rotor as wide as the diameter, or the radius actually. So that means it's only going to be, if I look at it, so the radius is about 160 millimeters, 170. So if I yeah, I need to take at least one segment off, because it'll be wasted area, which is not a big deal, but it's going to be the biggest Newman motor I've built to date. All right, stay tuned. Welcome back, guys. So this is tedious work. So I have to glue the inner guide, or actually the outer guide, first, all the way around on both sides. And then I have to glue the inner guide using the jig I made. And because of all of this placement of guides and stuff, the balance of this thing is going to be in big question, because I'm not doing things precisely the way I usually do with the 3D printing. I mean, I can always balance it. That's not the issue. It's just that, having to line these up, I used a plate. This is a ceramic plate that's completely flat, and I used, a square, a special machinist square, to try to line it up. But even still, even with all that, it's going to be janky at its best. Stay tuned. All right, guys, welcome back. So I took off one segment, and I think that is more balanced. There's the bearing on either side. Yeah, that is much, it's not so tall. And so, yeah, I think that's much better. What do you guys think? Anyway, I got a lot of work to do on that. I have to kind of like bondo it up because although it was difficult to take the segment off, it wasn't that hard. All right, stay tuned. All right, welcome back really quick. So as I do this, I think of different ways I could have made it better. And one obvious one was instead of making two pieces like this, make one piece. So connect these so it would essentially be one piece that's shaped like a backwards C. That's what I should have done. In fact, I may still do that because that would ensure several things. I wouldn't have to worry about gluing these separately. It would be easier to center the whole unit, although it would be heavier on this end than that end. But I planned on making a piece of equal size to fit over here to the stop the magnet from sliding out like this, although I don't think it would because of the inaccuracies of this. I think it would hold it in place. Damn. I think that would have been much better if I just made this one piece, and it wouldn't be hard to do. Oh well, live and learn. Stay tuned. All right, welcome back. So again, this is the goal. And the more I think about it, the more I should have made it into one piece. It's not too late. But man, it's a lot of work down the drain. Actually, it wasn't really a lot of, oh yeah, it was. The 3D printing does it by itself, but, man, why didn't I? See, I moved too fast. I should slow down. Well, let me keep going with what I have. It all depends on how hard it's going to be to get those in position, because those are going to be the toughest ones. Because I got to be careful not to crazy glue this thing in there. All right, stay tuned. All right, really quick. So, in testing this template or this jig, I realized that it's not going to work. It's better if I use a smaller one like this. And see, it does slide in and out. I had to make sure that when it was like this, would it be able to slide in? And it does. But I'm going to use a sacrificial one of these. I think I have a black one, and use it to just tack those into place. And then later on, after I'm all done, I'm going to come back and I'm going to use really thin CA glue and button all these up tighter. All right, stay tuned. Yeah, so the smaller jig works great. And so I believe that the inaccuracies, because of course it's not going to be absolutely perfect, will make it so that when I slide this guy in, it's going to be tight because it's not a precision fit. You know what I mean? Yeah. And this guy slid right out nice and easy. There was no binding. I made sure of that. I didn't want to get this thing done and then realize that this wouldn't slide in, that this guy wouldn't slide right in. All right, stay tuned. All right, so far so good. You see, I've got it, and it only takes a few minutes with the clamps because this is, after all, CA glue. So I need to take a break in the action because my wife is rebuilding a Fiat. she's something else. She's rebuilding a Fiat, and yeah, it's a really old Fiat from Italy that the family has had for a super long time. And so she's redoing the whole thing and needs help getting the gas tank in. Anyway, stay tuned. Really quick, just a demonstration to show how this thing just slides in and out like that. So yeah, one half is done. I got to flip it over and do the other half. And then I'm going to get back to working on the Newman motor. All right, guys. Ciao. All right, so I've got it done. I have all of the guide pieces for the bearing, for the magnets in. It looks pretty cool, but will it work? So before I try to muscle in one of those, it works when I use the test piece. Oh, I can't do this one-handed. It works when I use the test piece. See? Slides in and out nice and easy. And this actually isn't even a test piece. This is one of the actual magnet holders. But before I muscle any of those in, I need to let this set just for a little bit, and then I'm going to go over it with super thin CA glue to really try to, cement it in. Because the only thing that's going to be holding these magnets from flying off are these little housings or holders or whatever you want to call them. So what I may end up doing is printing out a very thin but somewhat wide band of PLA to go around the whole assembly when it's done, so that if one goes, it can't because it's being held in by all the others. And it would be super thin. I would print it in what's called vase mode, which actually prints it like less than half a millimeter, almost like, I think it prints it in 4/1000ths. So it's super thin. You can actually see through it, which would be kind of cool if I used like clear PLA to do that. Oh, but anyway, that actually didn't take so long. I thought it was going to be, I was really getting anal with it. And then I said, no, you know what? It's not going to be perfect, but it looks pretty good. So now I want to start working on the Newman motor. That's going to be a whole new nightmare. All right, ciao. So just like I thought, it fits in there, which is great, but it's a tight fit, which is really good. I knew that the inaccuracies of the way I put this stuff in there, I knew it wasn't going to be absolutely perfect, but I can't do this one-handed. It slides in and out like it's supposed to, which is very cool. I still gotta, so I haven't CA glued it up because I've been working on the Newman motor. So let me show you what I've been doing with that. Walk this way. So I use that Bondo stuff on the outside of the two halves of the coil assembly. And of course, they have to dry and I have to sand them and then redo it again and sand it and, the whole shebang. But yeah, so far so good. Everything seems to be working as planned, which is kind of scary. All right, later guys.